Okay, so welcome members. Today we are going to see a new topic called set theory. In most cases, probably we are going to be dealing with sets, but please don't forget to subscribe to the channel. Okay, what is a set? A set is a collection of well-defined elements, stroke objects. Okay, we have two types. There is what we call a finite set and an infinite set. What's the difference? A finite set is a set where all elements can be counted. So you know the elements, you know the exact number of elements in that set. So that one we call it a finite, or you can list them. Then infinite set, a set with unlimited number of elements. So this set, you cannot count elements in it. For example, if they tell you a set of even numbers are many that you cannot count them. So that one we call it an infinite set. But here when they tell you a set ABC, this one has specific numbers. They are defined as A, B, C. So for them you can count them, but that they are 3 elements. But for infinite, you can never count them because they are many to infinity. E.g., this set is incomplete. It tells you that there are more elements coming. So this one is an infinite set. Or a set of even numbers, prime numbers, and so on. A subset, a smaller set that is contained in a larger set, we are going to see that. A universal set contains all elements or objects under consideration. So if we talk about maybe even numbers between 1 and 2, then also talk about prime numbers between 1 and 10, between the 1 and 10, those all the elements, all elements in A and B is a universal. A Venn diagram is a diagram that shows the relationship between any two given sets. So if you have any 2, 3 sets given, then if you put them, if you show the relationship between them using 2 diagrams, that diagram is called a Venn diagram. Let us list set notations and symbols. So this looks like N, it's called intersection set. Then U, union set. This one represents an empty set, all this. Then this one is for a subset. This one is for a universal set. Then this one will say it's a complement of a set. Then this one already tells us the number of elements in that set. So here you count those elements. So let us see some examples here. Given that the set A has elements, we always use curly brackets when we are listing elements of a set. So these curly brackets. 1, 2, 3, 4, up to 8, and set B 2, 4, 6, 8, 10, 12. Then they are telling us find A intersection B. Now A intersection B, it means the common members to both sets. So when you come here, you have to first of all show those elements that are common to all the 2 sets. So set A, we still have a 2, also have a 2 here. So this member is a common member. Common also here. Then we see we have a 4 also. We also have a 4 here. We have a 6 also there. We have an 8. We also have 8 there. So those are the only common elements. So we have 2, 4, 6, and 8. Now you list them. You start this is just an intersection B. So you list those members. We put them in curly brackets. So they are 2, 4. And then you cross. So those are the common members in both sets. Then here they're telling us that number of A intersection B. Whenever you see this N, it means that you have to give the specific number. In simple terms, you count the number, you count those elements. So this is our intersection B. Now you want to count them. This is 1, 2, 3, 4. So there are 4 elements. When you come to A union B, now this one, it's a set that contains both members of A and B. So we have 1, 2, 8. Then we have a 10. Then we have also 12. You see that this 2 is already here. The 4, the 6, then the 8. You should not repeat elements from one set to another. You write it once. So these are the elements in A union B. They There are elements in A and B. All of them are here. Then this number means that we are going to count them. So just come and count. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So there are 10 elements. So that's all, members. I wish you the best. Now we wait for the next lesson. We are going to see Venn diagrams. I wish you the best.